started. Hi, I'm Philipp. Let's talk a bit about containers and monitoring and logging and all that stuff in general. So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. I'm part of our infrastructure team, and I always say this is kind of a Unix pipe. I kind of piped it out into developer advocacy. So at infrastructure, we do automation, we do AWS, we build Docker images, we all do all the things, and then I'm kind of trying to go out in the field and talk about all the nice stuff we do. And the talk is really about like kind of logging and monitoring all the things, and let's see where we can go. So just to get a general idea, who is using more than 5 servers or containers? Anybody? Quite a few, okay. So how do you log? Who is using SSH and tail? Anybody? You can admit it, it's okay. We're all friends here. Because if you do, there might be better solutions or options. And yeah, you will figure out at some point it's kind of getting painful if you don't know which window is what, and you kind of like just connect to random stuff and try to grab for some strings, and you don't get anywhere. So that is kind of the point normally when people figure out, well, maybe we should have some form of centralized logging and see what is actually going on in our system. And yeah, there was the infamous ELK Stack, which was Elasticsearch, Logstash, Kibana, which lots of people were using. Who is familiar with that one? Who has heard that? Who is using that? Okay, also quite a few. Yeah, and you can see it was called an ELK, and the logo was also the ELK, and we even had a plushy ELK, and we were handing out the plushy ELK at meetups previously. And then this little fellow came along, and that is Beats. Who has heard of Beats? Okay, that is way fewer. Okay, so ELK was, or is still nice, and you can totally use it, but we added this one component here, which is Beats. And the advantage of Beats is that it's more lightweight. Since it's written in Go, you get a native binary, you don't have any dependencies, and it will just collect information as efficiently as possible, and then forward it. Since this is a Java conference, you probably have the JVM on your servers already, so that is not a big issue for you. But for others, it was always an issue to have just a JVM for logging, because Logstash started off as a Ruby project and then went on to become a JRuby project, so you needed the JVM or at least a JRE. And if you were using some other programming language, people were not that keen on adding the JVM or JRE just for logging. So they always were looking for something else and more lightweight and without the virtual machine. And that is what Beats give you. The problem is that the Beats kind of killed the ELK, or maybe killed is too drastic. Let's say the ELK is just, we're trying to retire the ELK. Because there is no B in ELK. Kind of obvious, so we need to come up with something else. And then we tried with this one. That is the BELK, or the ELK B. And you can see, like, you have the B and the ELK horns, and it's kind of a neat idea. And one of my colleagues in engineering, he was so fascinated by that, he printed stickers on his own with that. Like, we never had official stickers with that, but you might see somebody with it, because somebody in the engineering team actually printed them himself. And then marketing was like, yeah, we're not so sure. Like, this stack is all about scaling, and that naming doesn't really scale. Because what happens if we add another open source project? Like, then we need to change the branding again, and it's a lot of work and it takes a lot of time. So I think still the majority of people I talk about ELK, even though we tried to get rid of the name ELK more than a year ago. And even internally we have something called ELK alert. So whenever somebody does a meetup or anything like that and calls it ELK, marketing will try to reach out and say, hey, it's great that you're doing that, but we're trying to change the ELK name. And yeah, what did marketing now come up with? So now they kind of took the boring one, but this is the most scalable solution. We just call it Elastic Stack, since that is the company name. And we put all the open source projects we have right now, and which might come in the future, that will always be like in the Elastic Stack. And it's kind of like strengthening the company name a bit, but it's also more scalable since we're always about scaling. And yeah, you can see, you probably saw different logos previously, like our Photoshop skills improved a bit as well. So this is these are the new logos and how all the projects are structured together. So you have the beats, which are like lightweight agents, shippers, forwarders, whatever you want to call them. They collect all your information. they can then either forward your information directly to Elasticsearch, or they can forward from beats to Logstash. Logstash can then do the parsing and enrichment, whatever you need there. And then Logstash can talk to Elasticsearch. Elasticsearch just stores all the information, and in Kibana you can actually visualize that data. And it's kind of a shame, I think we have a Kibana talk at the same time, which I also wanted to see, but yeah. So watch the video afterwards if you want to see more about Kibana. So let's get into the logging and monitoring part. So we have beats, that's kind of like a more fancy version of the same logo. And the first one, that is kind of the Logstash forwarder. The Logstash forwarder has been deprecated, but that was previously the thing that collected your logs and forwarded. That is taken over by FileBeat. So as we said, that's written in Go. You have native binaries. It's very efficient and lightweight. And I always describe it, it's pretty much like tailf, but it's over the network, and it's kind of on steroids. So it is more powerful, and it has more features than just doing tailf and sending stuff away. And if you still need to do parsing, you can either do that in Logstash, or we have a new node type called ingest node, which can also parse. And people are sometimes confused, like, what is actually parsing? It could be like you have a log line, and in that log line you have like an Apache or Nginx access log, and you want to extract specific values out of that, like the return code of an HTTP request. You want to get out the user who did a request, the URL, how many bytes you sent, how long it took, etc. So you can parse that, but parsing could also add some enrichment. And enrichment would be like you have an IP address, that is the first line, and the rest is then enriched. Like that is only added from the IP. So we did a GeoIP lookup here that happens automatically in the background. It's kind of like locally sitting on the parsing instance, like either Logstash or the ingest node. They have the GeoIP database locally, and will then just do this lookup, like this IP address is probably from Houston in Texas. And you get the geolocation, so you can actually draw that out on a map. And that is all very nice and easy. The other nice attributes that you get with FileBeat are you have at least once delivery, so it is guaranteed that your messages are delivered, otherwise you will retry. We have back pressure, so if the destination system is overloaded, the sending system will kind of slow down or stop sending entirely, and you have graceful downtime. If the receiving system is down, the sender will know that and will kind of like, remember, I have sent everything up until here, and will only continue later on to send more stuff afterwards. That looks pretty much something like that. So we call those things that you configure prospectors. So the prospectors are basically, you say this file or directory, that is what I want to monitor. And then for every file in there, you have a so-called harvester. And the harvesters are kind of like collecting what is in a file. And then we put all of that data into a spool. So that is the spool over here. That is where all the messages are taken and put. Then the next step is the beats find some system where they send the data to. For example, here I'm using Logstash, so I have like on your dozens or hundreds of servers, you have the beats. And they will find a Logstash instance and keep sending to that Logstash instance. And they will round robin between them, and if one of them is down, they will find another one. So as long as you have multiple Logstash instances, that should be highly available and very reliable. And that is actually how stuff is sent. So you've seen we have collected all of these logs. And what is then done is you see in the gray area, we have some stuff has already been sent and acknowledged. And then we pick up that yellow piece, and that yellow piece is sent and in a batch. Like for efficiency reasons, we're not sending single messages, but we always batch them up together. And then we're waiting for the acknowledgement from the Logstash instance. And once the Logstash instance has acknowledged that yellow area, it will be colored gray, and then the next batch will be sent. And if you don't get an acknowledgement, we would resend after some time that yellow area until we get an acknowledgement. And it works very well in the background because we have a registry file which knows, like, in each file that we are harvesting, we have sent and acknowledged everything up until that specific point. So even if the other side is down or we don't get acknowledgement, so the process crashes or whatever, we have that in that registry file, and then we know, okay, we still need to send that bit from that file. And we will try not to send any duplicates because we have that registry information. And that even works if you do a file rotation. So if at midnight or whenever you have configured it, you rotate your log files, and you have just written something and then you're rotating and the beat has not been able to collect that information yet, it will still know that it's the same file since this is based on inodes. I have no idea how this works on Windows, but on any proper operating system, you have inodes where you have kind of the pointer to the file regardless of what it is currently named. And that is how it will keep track of like what you have collected and what you have sent over the network. And you can also do like more fancy stuff. Like, yes, you're not really parsing on the node, but you can say, I only want to send everything that is error or warn, and I want kind of to exclude all or everything else. And you have like, you can say, I want to include lines, I want to exclude lines, and you can also define patterns to exclude files. So here you can just say like, I want to log on debug locally, but I don't want to store that all centrally. It's like too much storage on the central node and too much network traffic. I'm only interested in warn and error messages over the network to be centralized. So that is that configuration. Or if you have multi-line statements like stack traces, those are generally a pain because what you don't want to happen is that every line of the stack trace is an independent message, because then you totally lose the context. That one stack trace should be treated as one block. And then you need ideally some rule on the file beat where you collect that to actually put together that one stack trace into one message or one log event actually. And how you can do that is you have these patterns. For example, we can say if the thing starts with space or the caused by, if it does that, that is kind of the following of a start line, and everything that starts with that belongs to the previous line, and only if we have neither a space nor a caused by in the beginning of a line, then it's another message. And that would group that entire stack trace together, and you could send it as one log event then. So this is how to properly collect that. Or if you want to do even less processing and parsing, you could store JSON directly. So any structured log format is generally kind of what we would have ideally. So in that log format, you would have a proper timestamp, and you could have, if you use MDC logging or anything, you could just enrich that with other information, and you can collect everything in that JSON file, and then just send JSON and can put it into Elasticsearch directly, since that is also JSON. And recently we added something called FileBeat modules. They can just monitor specific processes. They know on your operating system, Nginx, for example, logs to var log Nginx access log, and it knows like the default pattern of that file looks in a specific way, and it can then parse that automatically for you. It will enrich the IP address and the browser information for you, and it will even store like dashboards automatically for you. So you don't have to do anything else, you just need to enable the module, and then it will do all the parsing and enrichment for you automatically. Okay, and then Docker. So with Docker you have lots and lots of options, and we'll take a look at 101 options. I hope we manage in time. So if you go to the logging overview of the Docker API, you will see that these are all the options you have. And some of them can be used to log from your containers with our stack. So the first one is the default, that's the JSON file, where you can see your Docker log works, Docker logs work. You have the meta information, it's the default. It's very easy to get started. Main downside is it's potentially slow, since JSON's logging can be a bit slow. And you will need to configure file rotations explicitly. So by default, that one file will grow without bound, which is okay if you deploy your Docker containers very frequently and you will get a new file. But if you have a persistent volume or like something that runs for a long time, like if you have a database running in a container and that's running for weeks or months, that file might get very, very large, and then you will need to configure the rotation yourself. The next option is syslog. Like you need to run your own syslog server, but then it's very powerful because then you can really say like, how do you configure path? How does file rotation work? You just need to provide that custom syslog server, and you have kind of the downside, like since you need to serialize and deserialize for syslog, multi-line statements and everything regarding metadata is kind of more painful than it has to be. Then there's journald. Thanks to systemd, there is kind of no real way around journald anymore. works with Docker logs, it has meta information, it is widely available. The main downside for us is that we don't have good journal D integration yet. So somebody from the community stepped up and thankfully created the JournalBeat module, so you can use that. And I've even talked to the author of that, like he would prefer that we take it over and maintain it from now on. I think we will do that. We just need to find time and resources to do it. But yeah, at some point we will have JournalBeat or journal D integration in the beats. Then there is Gelf, the Graylog extended log format, which is nice because it has a direct Logstash connector, so you can just send data directly from your containers to a Logstash instance. The main downside is, or for some it's an upside, it's that it's UDP, so it's more lightweight, but you can lose messages, and you always tend to lose the messages that you wanted to see. And since it's UDP and it's fire and forget, there is no back pressure, there's no graceful downtime. It's just like you send, and if the receiver is not ready, the messages are just lost in the ether. And the final option would be you mount out the volume. So you just have your application, you mount out a specific volume where you put your logs. Like if you have, I don't know, a well-behaved Spring Boot or JEE application and that does file rotations for you and everything, you can just log out to a specific location, mount out that volume, and then collect it from there with FileBeat. Downside is, if you only mount out the volume, you normally lose the metadata from the container around it. So you don't really know from which container that file was if you don't kind of keep track of that somewhere else. Luckily, 101 options were only binary, so it was not that much. But right now, so the best options probably would be log JSON, that is the default. Use syslog or a volume. Like for my demos, to keep it simple, I normally rely on JSON. In the future, potentially as soon as we have journal D is a better option, or we'll see. How to add metadata. So you want to have, like, you have your log file and you want to know like which tags were applied to that container or which name has been that container, because that is often very useful afterwards to say like, just give me the logs of this specific container with that name or those tags. Right now we have a slightly hackish version in the Alpha 2 version of Elasticsearch, which will come out later this year. Version 6 will come later, and right now the latest version you can get is Alpha. So what you can do is, if that makes sense, so we have the input with the log. We say the path is, I don't know, whatever containers you have the ID of the JSON log. Then you say, okay, that's the document type is Docker, that's JSON. And then you say I add an ID to that, which the field I call cgroup ID, and I give that the ID. And then we have a so-called processor. And the processor is basically saying, I look up this ID in var run docker sock. So on the docker sock, it's looking up the ID. That is in the field's cgroup ID. And then I will add automatically metadata to that for you. So that is kind of hackish. So in the next version, which will probably be a beta already, that's not out yet. It will be in, I don't know, 1-2 months or something like that. Then you can just say, okay, it will know if you add the processor to add Docker metadata and it sees something like varlib Docker container and some ID, whatever that ID is, then it will add the Docker metadata to that automatically. So you don't need to do that explicitly anymore. That will come out later this year. Okay, next up, Metricbeat. It started off as Topbeat because it was doing what Top is doing, so it's collecting system metrics. But yeah, those are the system metrics like memory, CPU, I/O, network, whatever. But we added more pieces to that. So it then added metrics from applications. So by now you can monitor web servers, databases. You can ping Jolokia, like it's very easy to get that up and running if you have a JMX endpoint through Jolokia. You can collect information from Prometheus endpoints, and we also do, we can support the Docker API. So you can collect data from the Docker API by now. In the beginning, we didn't have the Docker API yet. Back then, we were relying only on proc. So we were just collecting the cgroup information from /proc. That was built into the system module. And that had a very big advantage security-wise, because as soon as you have access to the Docker API, you have access to the Docker API and you can do stuff. And maybe your metrics system should not be able to access the Docker API and, I don't know, stop a container or start a new container or whatever. But once you have access to that, you have access to it. But with proc, you can just mount proc read-only to a Docker container, and then you can just read that metric information. And you don't have any security issues around that. The other big advantage is it will run with any runtime or container technology, so it's not limited to Docker. Anybody using anything but Docker, like anything else? Anybody? Yeah, that's what we always see. Like this is a very nice attribute, but nobody really cares right now. But in theory, that is a very nice attribute. So if stuff changes in the future, you don't really rely on the Docker APIs. It will enrich everything with the cgroup data, so that is very nice. The main downside is it doesn't support anything that is Docker specific. So names and tags from Docker, those are not added to that information. And then people are always like, yeah, but we only use Docker. We only care about Docker. We want Docker. And then somebody in the community, oh yeah, actually this is the right Docker logo, I think. So at some point, Docker kind of will eat you and everybody else, and you are the little fish. Docker will eat the little fish. So at some point, someone in the community created a beat. It's, by the way, we provide a base library, so creating your own beats is very easy. We kind of do the hard lifting, like we communicate with Redis, Elasticsearch, and Kafka. We do security parts. You basically just need to fill in, like, this is the API or the file system or whatever where I get the information from. This is how I get the bits and pieces out of that. And this is how to forward it. And we kind of like provide all the boilerplate for you around it with the base library. And you kind of only need to put in whatever is appropriate for your application. And they were nice enough to, like, somebody was nice enough to write that beat. And then they did a 1.0 release, and they even wrote a blog post on our blog about that Dockerbeat. And then we kind of had to remove Dockerbeat. Because Docker Inc., the company, complained because they have the trademark on anything that starts with Docker. So any project on GitHub, for example, if your project starts with Docker something, Docker can have that taken down because they own the trademark of anything that starts with Docker. Just beware. So as soon as you're getting bigger and successful or just stick out for some reason, you might have to rename your project, like, yeah, Java slang had to do as well. So trademarks are always an issue. Be careful when you use somebody else's trademark. And then we were thinking, like, okay, how could we rename that? And what we came then up was that we simply called it Dockerbeat because Docker doesn't have a trademark on Doc. And at first we thought about just removing the E, so calling it Dockerbeat, but then we went for Dockerbeat. But that was also only kind of a temporary solution. And already back in 5.1, which now we're at 5.4, that API was actually added to Metricbeat. So if you get any current Beat version, you will have the Docker API built in by now. You just need to enable the module and then you're good to go. What if you want to use the Beat to monitor another system? For example, you just want to monitor the host system of that. Then you just need to mount a few things like proc or the hostfs. You can mount them read-only, and then you can extract metric information from that. And then you just say, that is my Docker container that's running, and I want to monitor that host system. If you want to monitor an application, like in that example would be MySQL, you obviously need to be able to access the API to get the metrics out of that. And for that, you will probably just need to link together the containers in the right fashion. So here we just have Metricbeat running, and we link it to MySQL and give it the credentials to access your MySQL database. So it can extract the metrics from MySQL in that example. And generally, our recommendation would be to run it as a sidecar. So you have all your containers running, and then you have Metricbeat running there next to it. You don't need to package Metricbeat into the containers with your applications. And you also don't need to install it on the host system. You can totally install it on the host system, but you don't have to. Like if you prefer to have it as a sidecar, that should generally work. Yeah, the metadata enrichment will work in version 6 as well. And also in the next major version, we will have proper Kubernetes integration. So we will be able to do the same kind of enrichment where we get metric set data from Kubernetes and just enrich your processes. So you just need to tell it, okay, this is where you connect to Kubernetes. Just extract these informations, and then you can see, okay, these are all the pods I have running, or these are all the nodes, containers, whatever. And that will be enriched automatically. And this is still a bit work in progress, but this is one of the dashboards we might include in the next version. I think it's already in one of the alphas now, where you see you can group it by Kubernetes namespace, for example, and you see the CPU usage and memory usage by namespace, or whatever you can make out of the information that you extract. Then we have another beat, which is called Packetbeat. So who's using Wireshark? Wireshark, anybody? Wireshark? Few? Okay. So Wireshark is nice as long as it's one kind of like big monolithic thing. But as soon as it's more of a distributed system, and then you would need to run Wireshark on lots of servers and combine all the traces that it has collected. And Packetbeat is using the same base library as Wireshark, libpcap. And it's doing exactly the same thing. It's just kind of in a distributed fashion. So Packetbeat is running somewhere, collecting the network headers, and from that information, it extracts a lot of information. So just from the headers, it knows, okay, this was a request, and this was the response. The whole thing took 100 milliseconds. The protocol was HTTP. The response code was a 200, and the URL you hit was foobar. So it can parse a lot of information out of those headers and will then just store that again in the stack, and then you can just visualize it and search it. And the protocols that we currently support are something like this. So some of the databases, HTTP, AMQP, and DNS. So these can be parsed and stored. And then, if we don't support the protocol, we can still see kind of the lower level information on TCP and IP level. We call those flows. So we know who communicated with who, how much traffic has been generated, have there been transmissions, and what is kind of the temporal flow of data. That applies if your protocol is encrypted, since we cannot see into encrypted traffic, which is also probably a feature. And if we don't support the protocol in general, then we cannot see that. But we still can do flows and see just who is talking to who. And again, you can run that as a sidecar, and then it can just monitor all the containers on your server and collect that information. Then we have another beat, which is called Heartbeat. So since we have our own cloud service, they have a lot of instances, and we were using Pingdom and other services to ping them frequently. And at some point, somebody in the cloud team was like, yeah, we have the beats, and they're kind of doing the same thing. We should just write one to ping stuff. And then somebody started writing that beat, and then the beats team took that over, and it's called now Heartbeat, so that can ping a service, and you can define like ping that HTTP endpoint, or just TCP or ICMP or HTTPS like every 10 seconds, and store the result. And the result will be either up or down, but it will also include stuff like response times. So it will know how long did the DNS lookup take, how long did it take to establish the TCP connection, HTTP connection, and TLS connection if you have it. And it will store all of that, and then you can see like which part might be slow, or you can see spikes like suddenly TCP connections take longer than they used to. So you will see a breakdown of how long does it take to establish the connections to your services. If you have to use Windows, we can also do Windows events. So we can collect with something called WinLogBeat. We can collect Windows events and store them into a central fashion. Though that is not really that container specific. Okay, so you want to have Docker containers. We have projects for each one. We named them correctly right from the start. So we didn't start with Docker something and then had to rename. We always had our product name first and then added -Docker. So if you want to get any containers, these are kind of the official places. If you run into issues, open an issue. but please don't let us be Docker support, because a lot of people think they will combine two complex systems, like Docker is kind of complex and Elasticsearch is also kind of complex, and they think like if they know neither of them and they combine them, it will be much simpler. And we got a lot of very interesting questions about basically Docker support. Yeah. And this is kind of the minimal example where we have Elasticsearch and Kibana, so just the two of them running containerized together. So we set up Kibana, we bind it to the default port 5601, and also link it to Elasticsearch. And Elasticsearch is also running on its default port 9200. We have a persistent data volume, which we call ES-Data1, which we mount out, and then we start that. Is there anything unexpected in that Docker Compose file? Any guesses? Or anything that you were not expecting? Are we using Docker Hub? Are we using Docker Hub? No, we're not using Docker Hub. That is the first thing that is very surprising, because what most people do is they go to Docker Hub, they search Elasticsearch, and then something will plop out. And if you go to that page and look up what is that something, it will say, this is Elasticsearch official. The thing is, at least for that image, official means it's Docker Inc. official. Like it has been provided by Docker Inc. It was never Elastic official, even though people get very confused by that. These images are now deprecated since we have our own registry. So as you can see, our registry is on docker.elastic.co. And some people complain and say, like, why do you need your own registry? Like, somebody even accused us of like being very elitist. Like, nobody needs to have their own registry. Like, there is no point. Like, we have two reasons why we want to have our own registry. The first one is we have very detailed download statistics. So we could look up how many people in Spain downloaded Elasticsearch yesterday. And we could even see in what version. And that drives the product team quite a bit. So we know, or also the marketing team, we know like which regions are more and more active, like which versions are being downloaded, are there any spikes or slowdowns. So we take a little, or we gain a lot of insights into that. And I actually forgot, we recently did something, lots of people probably do for development Docker pull, but I think we had 800,000 Docker pulls of our products last month, something like that. Don't nail me on the number, but we had a lot of downloads on just the Docker containers. And the second thing is we have our own cloud service, and that is also based on containers, and we have an SLA for that. And we kind of guarantee that if you want to enlarge your cluster, we are able to spin up a new node with a specific version for you. And we're not really satisfied, A, with the availability of Docker Hub, and B, with the performance of Docker Hub. And yeah, that's another reason why we wanted to do that ourselves. And only if you kind of own the entire stack you rely on, then you really can provide SLAs. Otherwise, you're kind of like at the goodwill of somebody else, and we didn't want to be there. The other thing that is not that obvious here is that we don't have latest. Is anybody using latest? Anybody agreeing? Or let's specify like latest in production. Anybody using latest in production? Okay, it's maybe fine for development, but as soon as you're going to production, that is pretty much the YOLO approach. Like whatever is latest, just give me that. And especially for anything that is persistent, that is probably not what you want. Because what would happen if we had latest, like we had latest for 2 weeks or something like that when we started, and then we kind of rethought it, and then we were like, yeah, latest is really stupid. Because what would happen is somebody starts a cluster today with 3 nodes, and in half a year, they add 2 more nodes to that cluster, and they also add them as latest. And then you will get a totally different version, and if it's a new major version, you probably screw up your entire cluster. Or at least it will not work that you add your nodes. So that is why we insist that you actually specify the version that you're adding. It might be a tiny bit more effort now because you need to find the right version and put it there, but it will save you a lot of trouble later on. So there is no latest from what we provide. The other thing is we started off with Alpine as the base image for Elasticsearch because everybody wants to use that, or at least a lot of people are very vocal about that and say like, oh, the images are so tiny. We want to do that. Turned out once you put the JDK on Alpine, it's not that small anymore anyway. And we had lots of bugs and issues with Alpine. We're sure it will improve, like instead of glibc, they have their MuCL library, and that is, yeah, it's smaller, it's probably nicer, but it is not as battle-proof or battle-hardened as glibc. And we ran into a lot of like weird bugs which were fixed, but it was always an ongoing struggle. And also we have a machine learning component now, which is written in C++, and that doesn't really work on Alpine yet. And we didn't really have the resources to port that over to Alpine. So we now ditched Alpine, and all our images are now based on CentOS, which will make the Red Hat guys very happy. The decision was mainly, A, you should not really care too much what the base image is, and B, most of our big customers who might want to add support or buy support for an operating system and the base image, they are on something that Red Hat owns, because most of them are in the US. So that's why most of our images are on CentOS now. Though there are discussions if we want to provide different base images for different things. And sometimes people even ask for Windows-based images, which we are not too keen on supporting, but we'll see. So if you want to demo that now, like I have two demos. Like one is kind of a Vagrant box, and we have like lots of services running in there, and one of them is Docker as well. And the other thing is I have the entire stack just on Docker. And I will quickly demo like the first one, because there I have the alpha version running. So if I find my browser. So this here is, you don't really see it. If you run that, you can see I'm using the latest public alpha version. There are some bugs, especially if you try to import our default dashboards. Some of them, or quite a few of them, are broken. We will fix it again. But after all, it's an alpha version. Like 6 will come out later this year, but we will have beta soon, and then we have release candidates, and then we'll have a GA version later on. So bear with me, that is an alpha version. Stuff might break. So we have our 4 beats running here. I have FileBeat, Heartbeat, Metricbeat, and Packetbeat running, and all of them collect some information. Let's say I'm interested in FileBeat. And then you can see, or actually I can show you quickly my configuration. Let's make that bigger. So what I'm doing here is pretty much what you expect. I'm just saying here I'm collecting the Kibana log, that is just a JSON file. Then here I'm collecting information from my Redis container, so that I have a Redis Docker image loaded, and I just say like add that cgroup ID, and that will then be resolved by that metadata information. So it will say like this ID I have in the field cgroup ID in that field, look that up, and then correlate that with the name and the tags from the Docker socket. And that is what is kind of happening in the background. So to see how that looks like, for example, you could just say Docker container ID, though nobody knows the Docker container ID, that is super weird. You could just say Docker container name, and you see I only have one container running here, but it's my Redis, and then you could, for example, say on that little plus sign here, if you can even see that, we could filter down all my messages. And you can see over the last 15 minutes, I had 20 messages from my one container, which I filtered down here. And then you can expand that, and then you can see, okay, ID, that's the image name, that's the name. I didn't assign any tags. And then you can see that is the JSON log file, that is some typical Redis log. AOF rewrite child asked to stop sending diffs. So you can collect all of that from your containers, and that is very simple. The other thing you probably want to take a look at, or I can quickly show off, like we have a dashboard for Docker. And as I said, I only have one container running here, so it's not that. There could be more action, but you see, okay, one container, one is running, 0 paused, 0 stopped. I don't know why that is cut off. That is kind of part of the alpha version that used to work, but you know how it is with software, it used to. And then you can see, okay, CPU usage, memory usage, and network input and output of my containers. So you can see how that is working. And actually, the traffic is very like in and out is very similar. This is only because I have Packetbeat running here as well. And Packetbeat is sending all its traffic to Redis. And then Logstash is taking that traffic out of Redis again and processes it further. So I pretty much put the same information in as I take out. That's why in and out are so similar. And since we have 2 more minutes, let's see if I'm quick enough to actually build a new thing. You probably have not seen that yet, but we have something called the new visual builder. And here you can build much more powerful visualizations than you used to. So I will just call that one in. I say I want to have a sum here. The field I want to have is, there is something that is Docker network in bytes. That sounds very reasonable. And you can see, okay, we have some traffic here. And then I say I want to add the out traffic. So here I say out. Let's give it another color. Is red good? Let's stay with red. I say again, I want to have the sum. You say I take network in and out bytes. That sounds very reasonable. And you can see, okay. But here I have in and out right over each other. If you scroll over them, sometimes they're the same, sometimes they're not, as you can see on the number on the right-hand side. But that is a bit weird. Like, I don't want to have this olive color. And this visualization is actually very powerful. It is a pipeline aggregation. So here, I can actually do something with that data. So I can here say, I want to do a calculation. I have my data, which let's call it out as well. We only have one variable around here. And then I can say params out. That is my variable name I've had here. And then I say this, I want to multiply with -1. And then you can see, one is on the x-axis and one is on the y-axis. And then you can even fine-tune that here. Because, for example, that is not number, that is bytes. And that is actually bytes per second. And let's do the same thing here. So we have bytes and we have bytes per second. And now you can very nicely see how much traffic is being generated by your containers. And you can do the same for CPU, memory, or whatever data you have. Can be for containers, not for containers, anything. That's our new visual builder, and that should enable a lot of very cool use cases to show off stuff. So, to wrap up. I always compare the stack kind of to Lego. You have these building blocks, but there is some assembly required. So you need to put together the bits and pieces. It's not like a one-trick pony, so there are other components which are just focused on logs, or just focused on metrics, or just on business analytics or something. Like with the Elastic Stack, you pretty much can do a lot of different things. It can do container stuff, but it's not really limited to containers. But there is some assembly required. Like in my repositories, you will find kind of a lot of configuration scripts and see how stuff works. It will take 1, 2, 3 hours to kind of put it together the right way, but then you can pretty much build whatever you want and combine all the things together. That is kind of the entire stack. We've only covered the open source stuff, so that is kind of in the dashed line in the top left corner. We also provide the hosted service on currently AWS and Google Cloud soon. And we also have some additional commercial plugins which always are sold with support. That is how my salary is being paid, for example. Like, if you need these functionalities on the right-hand side, those are commercial, and we added machine learning recently as well. If you now say, okay, Docker is nice, but I only want to monitor my Java applications, I have another talk and kind of demo just for monitoring microservices or whatever you call them. It's just a distributed application, and you collect metrics, logs, and traces from a distributed application. And you can store all of that in the stack as well. For example, tomorrow there's a talk on Zipkin, and Zipkin also has Elasticsearch as a backend. So you can store lots and lots of stuff in one stack and then visualize as you see fit. And that's pretty much it. I guess we have time for questions. We have 2 minutes or something like that for questions. And we have stickers up front, if you still want stickers. Any questions? I don't see anything, actually. Anybody? Yes, there's over there. wrong side of the microphone.
Hello.
Hi.
Yeah. Do you have anything planned to be sure of to monitor the workflow? I mean, for example, sometimes you have some application where the logs are more important than even the application itself. And if you drop some logs, well, yeah, it's more problematic. So when you have a lot of containers, well, you can just look that you have logs, but you don't know all the containers you have running. So maybe one of these containers is not able to connect. Somewhere in the flow, you lose those logs. Could be a FileBeat, could be a log stash, which is not reachable by the FileBeat that's running for this container, or something like that. So do you have any mechanism planned or already available?
If your network is down, I don't think there is any automated resolution for that. We kind of assume that eventually your container will be available again. Or for containers, it will also depend, like, how do you actually collect them logs, like in a sidecar? And then it will depend on, like, how do you use JSON log and you just collect it from the file system, or do you use syslog? So it will depend. I mean, there is no automatic resolution for that, but generally, as soon as you're able to connect and you have that registry file, it will know, like, I have collected everything up until here, and that is the rest I need to collect. So as soon as you have the mounted directory still, or you have the JSON log or whatever you have, as soon as we're able to connect again, we will pick up from where we left off. But there is no way around broken networks or anything. Did that answer the question?
Yeah. I think, yeah, you have to do it manually, no? Like connect from the application to the Elastic to say, hey, do you have some logs from this ID, which is mine?
So the beat is generally pushing out the information. So you have the beat running, like either as a sidecar or on the host system or within your container. And that is kind of collecting that and then sends it off. So it needs to be able to connect either to Logstash or Elasticsearch, depending on where you want to send the traffic. But it will detect, like, the other side is down, and it will only send more stuff when the other side is available again. So it will ping if it's not available, and we'll figure out, okay, now it's available, and now I will send you the rest I have.
Okay, and from the FileBeat, can you get the information that he's not able to send the stuff? Or?
I mean, FileBeat will log it in its own log, but if FileBeat is not able to reach it, FileBeat will probably not be able to reach out anywhere else. What you could do is, unfortunately, alerting and machine learning are commercial, but they can, like, machine learning will probably detect, or you just define a rule, like that instance is not logging anything anymore.
Yeah.
So but that is more on the detection side. That is not really part of what the beat does, but that is more part of, within Elasticsearch, of course, you can define rules. Like if a specific container didn't log for the last 10 minutes, probably raise an alert. Though, since containers are very volatile and, like, you add them and you remove them, that is probably something that is better catered for with machine learning. It would take 5 minutes. Like, if you have the question afterwards, I can show you. It takes 5 minutes to find the right demo for that. But I can show you where we kind of, machine learning kind of knows, okay, this is the number of events that come in, and you probably have, like, a daily rhythm or something like that. So during the day you have more traffic, and in the evenings you have less traffic, so you also have less logs. But it will detect, like, suddenly you have more than normal, or you will have less than normal, or you will have suddenly 0 where you don't expect 0. So there are ways to automatically alert you. But that is not really on the beat side. That is more on Elasticsearch, where you just run queries and check for these conditions.
Okay, thanks. I'll drop by after to speak
sure.
with you. It's okay.
Any other questions? Or everybody ready for coffee? I think we have a coffee break now, right? Yes. Well, if there are no more questions, otherwise just find me, grab stickers, and enjoy your coffee. Thanks.